we're going to learn more about matter, what it is and what is it made of. So we already talked about how matter is related to our consciousness, and they have a tight relationship. If there's no consciousness around, then there's no matter around.
No matter what.
We also talked about how some scientists, some researchers, they actually working on a theory that we are actually in a computer simulation, in a video game. But whatever this experience is about, regardless of its fundamental nature, we still can learn about the relationship between things and use them to our advantage.
Taking advantage of a simpleton.
For example, even we don't know what exactly matter is made of, but we still can understand when we use baking soda, when we bake a cake, the cake gets more puffy and more delicious. So from now on, rather than getting caught up with the actual nature of matter, we're going to take a more engineering approach, a more pragmatic approach, and that is to accept what we know and just use them to our advantage, use them to make cool applications, to make life easier. So first we're going to learn what matter is, the things that we know we can categorize, we can label, so then we can use them. We're going to talk about atoms and subatomic particles like protons, neutrons, electrons, as well as periodic table of elements. So we mentioned that atom was proposed to be the most fundamental particle of life, that everything is made up of atom, and the word atom means something that cannot get broken down into smaller things. But nowadays we know even there are subatomic particles, meaning particles that are smaller than atom. So technically atom is a misnomer, but if you think about the smallest particle that still contains most properties of that matter, atom is still a good name. Now let's take a deeper look at atom. So atoms, they can be divided into two parts. One is the core, which is located at the center of the atom, and the other part is a cloud of electrons around the core. Now the core is among the scientists known as nucleus. So they mostly refer to it as nucleus. And nucleus is a Latin word and has the same roots as the word kernel or nut. So nucleus is at the center of the atom and is surrounded by a cloud of electrons. Now if we compare the size of nucleus to the cloud of electrons, we have to give an example of a football stadium, and the nucleus would be the same size of a ball that is sitting at the center of the stadium, and the cloud of electrons is actually the stadium itself. That's how the sizes compare to each other. However, almost the contrary is true about the mass of the nucleus and the mass of the cloud of electrons. So most of the mass of an atom is related to the mass of the nucleus, and the mass of the electrons are almost negligible. Now let's take even a deeper look at these subparts of atom. So we're going to introduce now subatomic particles. So the nucleus is made up of protons and neutrons. Protons and neutrons they have the same mass. They almost have the same mass. And together, they contribute mainly to the mass of an atom. And the other subatomic particle that can be found in any atom is electrons. Now, electrons are dispersed in this cloud around the core. But it's not a normal cloud, it's rather a mysterious cloud because we cannot exactly pinpoint the electrons and find out where their position exactly is in the space. We cannot really show a point and say, here's 100% there is an electron there. We cannot do that. We cannot pinpoint them. Rather, we can talk about the probability of their existence.
It probably is.
The word probability is key here. The probability of their existence in a certain shape, in a certain space. So, for example, we could say they probably are in this sphere, or they probably are in this dumbbell-shaped space, or they probably are in this dumbbell-shaped space. Later, we'll talk more about the electronic configuration. But so far, we cannot really pinpoint the electrons. We only can talk about their probability of their existence in a certain space. Just like when you're not home and you don't know where exactly your cat is. It could be in your room, it could be on the bed, it could be on the cabinet, but you're not sure. You can just talk about the probability of the cat being somewhere.
Where did you go, little kitty?
Protons and electrons, they have a great affinity for each other. They are attracted to each other. So if you leave them close to each other, they would like to stick to each other. And we express that by saying that electrons have negative charge, protons have positive charge, and positive charges and negative charges are attracted to each other. Just like the two ends of a magnet, they attract each other. Now, we really don't know why positive charges attract negative charges, and seems like science is not even capable of answering such questions. Asking why positive charges attract negative charges is like asking why gravity exists or why this universe exists in the first place. Although there are people trying to find the answers, but rather than answers, they just make up stories. For example, if you ask a prominent scientist why positive charges attract negative charges, they could say something like, oh, because that way energy is reduced, or things like to go to lower energy. And then they just kind of play with the words or make up a story. So if you get satisfied with that kind of an answer, you can think there is an answer for it. But I delved deep into it. There is no answer for why negative charges attract positive charges. It's like asking why this universe exists. Anyway, so electrons and protons are attracted to each other. However, neutrons, as the name suggests, they are neutral. Now you may wonder what these subatomic particles are made of. We do have more labels for the stuff that even protons and neutrons are made of. They call them quarks. But then you can go again deeper. What are quarks made of? Or what are electrons made of? And then again we get to the discussion of consciousness, vibration, energy, matter, and all that esoteric realm.
Oh, that's the good stuff.
So at this level, at high school level, or even undergraduate level, this is what we're going to need in most undergraduate majors. Now, atoms with the same protons can be categorized as elements. So if you have a bunch of atoms that they all have the same number of protons, we call those an element. An example of an element is oxygen, something that exists in the air that we breathe on Earth. We show this element with the first letter of its name, O, and we know it has 8 protons. Any atom in the universe that has 8 protons, that's an oxygen. And because the number of protons determines the type of the element, we write that number in this position in the left lower part of the first letter, and that number is actually called atomic number because it determines the element, the type of the atom. So we call it atomic number. Can you guess how many electrons this oxygen has? So I told you that protons and electrons are attracted to each other. So for every proton that exists in an atom, an electron shows up too. So they can be together. So the numbers of electron and protons in all atoms are equal. So there are 8 electrons in an oxygen atom. So in atoms, that's like a general rule. Atoms, number of protons equals number of electrons. Always. How many neutrons oxygen has? So different types of oxygen, they have different number of neutrons. Some oxygens, they have 8 neutrons. Some have 9. Some have 10. So these oxygens are sort of cousins with each other.
We're cousins.
Or as scientists, they put it, they call them isotopes. That's the scientific name. Iso or iso means the same. So the nucleus is what mainly contributes to the mass of an atom. So the mass of an atom is mainly made up of number of protons plus the number of neutrons. And for that reason, we call this number, the sum of protons and neutrons, we call it mass number. And we show the mass number on the left top side of the symbol of the element. So oxygen has 3 cousins or 3 isotopes. Oxygen, atomic number 8, mass number 8 plus 8, 16. Or oxygen, atomic number 8, and 8 plus 9, 17. Or oxygen, atomic number 8, mass number 10 plus 8, 18. These are the 3 isotopes of oxygen. But all of them, they have 8 electrons because they have 8 protons, and the number of electrons is always equal to the number of protons. Let's see another example. An element that you must have dealt with, carbon. When you do a barbecue, if you have charcoal, that's carbon. And again, we show the first letter as the symbol C. Carbon has 6 protons, so we show them here, left lower part besides the symbol. So number of protons, 6. That means the number of electrons is 6, 2. How many neutrons it has? Again, it has a couple of cousins. Some types of carbons, they have 6 neutrons. Some types of carbons, they have 7 neutrons. So if we want to show carbon with the atomic number and the mass number together, so we say C, 6, and 6 plus 6, 12. Carbon 12. And C, atomic number C, mass number is 6 plus 7, 13. So these are the 2 isotopes of carbon. Now something interesting happens when we line up all the elements in order of increasing atomic number, meaning increasing number of protons. If we do that, something interesting happens. For example, we will notice that the properties of these elements gets periodically repeated. So if, for example, here we find a gas, and again, a few elements later, we find a gas with very similar properties. Or if here was a solid that reacts with water in a particular way, then again we found here beside that gas a solid that reacts with water in a similar way, and so on and so forth. The properties get repeated. It was the case so much the properties of these elements, they would get repeated so much that even people were able to predict elements that by that time they were not known. They could say, okay, in this row or in this position that, for example, for P equals something, I predict that there is an element and has these properties that are similar to this guy, and I call it after my own name. That's literally how new elements were being discovered back in the days. So then after lots of elements were discovered, people started to make a table and put all the elements that have similar properties under each other. So something was invented, and that is called nowadays periodic table of elements. You must have seen it. If you Google it up, the names will come. Something like this shape. And the elements that are underneath each other, they have more or less the same properties. Each column represents elements that have more or less the same properties. Periodic table of elements. Now, remember I told you about the baking soda? So what kind of atom is baking soda? And the answer is, baking soda is not a pure element. Itself is made up of multiple atoms of different elements. So baking soda, which is very useful around the house, is made up of sodium, or its old name natrium. That's why we show it with Na, natrium. Sodium nowadays. Hydrogen, carbon, and 3 oxygens. So if there's multiple of one atom that comprised a compound, we put the number as a subtext to the lower right part of it. So when atoms get attached to each other, they form molecules. Molecule is the fundamental part of a compound, right? So many of a molecule makes up a compound. So when something is only made up of one atom, one type of atom makes elements, pure elements. If several types of atoms attach to each other, they make molecules. And when you have a lot of a molecule, you have a compound. We call that a compound. It's a combination of different atoms, so a compound. Atoms versus molecules, elements versus compounds. So that was a brief introduction to atoms and subatomic particles. Hope you enjoyed it. Let me know if you have any questions or comments.